Okay, looking at graphing lines. So how do we actually graph lines? So in a linear relationship, so say we had something like d equals 50t. We have two variables. So this could be like a distance over versus time relationship kind of thing. So we say that d is dependent variable, and that's the one that we're going to be putting on the y-axis, and t is the independent variable, and it's represented on the x-axis. So if we think about this as distance and time, our dependent variable distance its value is dependent on time, whereas time, it is independent. It does not depend on the distance. So that's why we have d as our dependent variable and t as our independent variable. So when we're talking about actually graphing lines, we have to follow a few steps. So our first step, construct a table of values. Our second, draw your x and y axis, plot the points, join the dots. Now, because we are drawing linear relationships, we should have a straight line. We should not have lines that go like this. It should only be, this is wrong, it should be straight. Okay, so first off, we're going to construct a table of values. Our goal is to draw the graph of y equals 3x. So first we need to draw a table of values. I like to create a table of values with at least 3 points, preferably 5, just so I get a good idea of what this graph is doing. So first you need to take the value of the x, substitute it into the equation to find the value of y. So here we have y equals 3x. So if I put my points as -2, -1, 0, 1, 2, it's good to put your numbers in chronological order. It's nice to have negative and positive numbers in there so you can see what's happening on both sides of the y-axis. Unless it's specified, you can choose whatever points you choose. It's always good to put 0 in there because then you automatically have one of your intercepts in play. Okay, so we want to draw the graph of y equals 3x. So our first x value, we've got x equals -2. So we substitute the -2 into our formula. So it's going in over here. Wherever you see this x thing, that's where it's going. So we have y equals 3 times -2, which equals -6. So we put a -6 in here. Then x equals -1, y equals 3 times -1, which equals -3. X equals 0, y equals 3 times 0, which equals 0. X equals 1, y equals 3 times 1, which gives us 3. And when x equals 2, y equals 3 times 2, which gives us 6. So there's our table of values. That's the first step that we need to do in order to graph this linear equation. Next, we want to draw a number plane. So you need to have your x-axis, that's your horizontal axis, your y, which is your vertical axis. Now, if you're not using grid paper for this, it is really important that you have even increments between all of your numbers along here or your numbers along here. The reason being, if you don't have them evenly spaced out in even increments, then what's going to happen is when we go to graph this line, it's not going to be straight and we're going to come into problems when we're relying on that graph to give us information. So now we're up to the point where we need to actually plot these points. So we want to draw the linear relationship of y equals 3x. So we use our table of values down here. So this here is our first ordered pair or coordinate pair. So that's telling us that we need to go across 2 and then down to -6. So here's where our first point's going to lie. Now our next point tells us we need to go across -1 and we need to go down to -3. So there's our next point. Our third point here, this is our origin point. So we're at 0, 0. Then we have 1 and 3. So we're going across 1 and up to 3. And our last point, we're going across to 2 and then we're going up to 6. Okay, so there's our points on our graph. Now what you need to do is you need to get your ruler, line them up, make sure that all of your points sit on the line of the ruler, and then draw your line. Now it's really important because we're talking about a linear relationship. This is an infinite relationship. So it goes beyond the points that we've plotted. So you need to put little arrowheads on either end of your line to say that this relationship is true for any value of y and any value of x. And our last little bit is to write somewhere on it that this is the relationship y equals 3x. For our next one here, we have just got to complete the table of values for the rule y equals 3x minus 2. So we've got 4 different points there, or 4 different x values that we need to substitute into our equation to determine the answer. So our first one, when x equals -2, we're going to have y equals 3 times minus 2 minus 2. So 3 times minus 2 will give us -6, minus another 2, that gives us -8. So up here we'll have -8. So when x equals 0, we're going to have y equals 3 times 0 minus 2. Well, 3 times 0 is 0, so we're just going to end up with -2. When x equals 2, we're going to have y equals 3 times 2 minus 2. So 3 times 2 is 6, minus 2 will give us 4. And y equals 3 times 5 minus 2. 3 times 5 is 15. 15 minus 2 will give us 13. So that one's when x equals 5. Oops, that 3 didn't come out. 13. So there is our table of values. Now you don't have to do all the working out that I've done down the bottom here. So all this stuff down here, you don't need to do this working out. If you can, in your head, substitute this value here and put it straight up into there and work it out in your head, you don't need to worry about the working out. If, however, you're finding that you're getting things a little bit wrong, it'll be a good idea to put your working out down there so you know where you're going wrong. And next one, we want to graph the line y equals 3x plus 1 on the number plane by first completing our table of values using our table given. When x equals -1, y equals 3 times minus 1 plus 1. So 3 times minus 1 is -3, plus 1 will give us -2. When x equals 0, we're going to have y equals 3 times 0 plus 1. So we're just going to end up with 1. When x equals 1, we're going to have y equals 3 times 1 plus 1, which is going to give us 4. And when x equals 2, y equals 3 times 2 plus 1, which equals 7. So now what we want to do is we want to actually graph these points on our number plane. So our first point goes across to -1 and then down to -2. So there's where our point is going to be. Our next one says we're going across 0, so we're staying here at the origin, but then we are going up 1. So our point is going to end up being here at the 1. And next point, we're going across 1, and then we're going up 4. So our point's going to be here. And our last point, we're going across 2. So we're going to the 2, and then we're going up all the way up here to the 7. So there are our 4 points. Again, we can see that they're forming a nice straight line when we put our ruler up against them. And we can draw our line down. Now remember, it needs to extend a little bit beyond on either side. And it's good practice to put y equals 3x plus 1 on our line. Okay, so looking at example 3, we've got to graph the line y equals minus x minus 1. So when x equals -2, we're going to have y equals minus -2 minus 1. So what we're looking at here is this -2. That is like saying we've got -1 times -2 minus 1. So when we're thinking about that, when we've got a negative and a negative, that's going to become a positive 2 minus 1. So we're going to end up with 1 here. When x equals negative 1, we're going to have y equals minus 1 minus 1. That's going to equal 0. When x equals 0, we're going to have y equals minus 0 minus 1. So that's just going to give us a negative 1 because that 0 is just going to vanish there. X equals 1, y equals minus 1 minus 1, which is going to give us minus 2. And when x equals 2, we're going to have y equals minus 2 minus 1, which gives us negative 3. Plot these points. We're going to go across 2. This time we're going to go up 1. We're going to go across 1, but we're not going to move up or down. We're just going to stay there. Our next one is 0, negative 1, 1, negative 2, 2, negative 3. So we can see we've got a nice little bunching of lines there. We draw our line across. We've got y equals minus x minus 1 as our line. Again, a little arrowhead saying that this relationship is an ongoing relationship. Okay, example 4. We've got mandarins are sold for $6 per kilogram. We have our table below. Which is going to be our dependent variable? Is our dependent variable going to be our weight or is it going to be our cost? I want you to think about that, jot something down. So I hope what you wrote for that one was cost, because the cost of our mandarins is dependent on the amount of weight. So our weight is going to be our independent variable in this case. We want to draw the graph of weight against cost. So if we're not buying any kilograms, it's going to be 0. If we're buying 1 kilogram, it's going to be $6, 2, 12, 3, 18, 4, 24, and so on and so forth. So what we want to do is we want to put some labels on our axis. So across the bottom here, we're going to make this weight, or W, and then up this side here, we're going to make this cost, or C. So I'm going to make these go in 1, 2, 3, 4, 5, 6, and then up this side, 6, 12, 18, oops, 24, 30, 36, 32, so on and so forth. Okay, now we're going to draw the graph of this one. So our first point is here at 0, 0. Then we're going to have 1, 6, 2, 12, 3, 18, 4, 24, etc., etc. Okay, now we need to join our line, making sure it's nice and straight through those points, and put a little arrow on it to say that that's going to continue. Now what I want to do is I want to use my graph to find the cost when the weight is 1.5 kilograms. So we go across here, we find 1.5, that would be here. We go up, and then we go across. So here is the value that we're looking for. So we're looking for the value that is halfway between 6 and 12, which would give us 9. So we can say, therefore, cost $9 for 1.5 kilograms. Now I want you to try for yourself. On the Google Classroom, I've uploaded the textbook of Cambridge Mathematics Standard Year 11. All the information's there, complete questions 1 to 9. And if you have any difficulties with that, please don't hesitate to let me know.